Good afternoon. Today is Monday, November 4th. NASA's Voyager 2 sends back its first message from interstellar space. NASA craft is seconded to travel beyond heliosphere, but gives most detailed data yet.
You left the story I made for you.
12 billion miles from Earth, there is an elusive boundary that marks the ages of the Sun's realm, and it started for interstellar space when Voyager 2, the longest-running space mission, crossed the frontier more than 40 years after its launch in the descent and defined signal from the other side that scientists have now decoded. The NASA craft is the second ever to travel beyond the heliosphere, the bubble of supersonic charged particles streaming outwards from the Sun. Despite standing up a month ahead of this twin, Voyager 1, it crossed the threshold into interstellar space more than 60 years behind. After taking the scenic route across the solar system and proving what remain the only close-up images of Uranus and Neptune. Now, Voyager 2 has sent back the most detailed look yet at the edge of our solar system, despite NASA scientists having no idea at the outset that it would survive to see this landmark. We didn't know how large the bubble was, and we certainly did not know that the spacecraft could live long enough to reach the edge of the bubble and enter interstellar space, said Professor Ed Stone of the California Institute of Technology, who has been working on the mission since before its launch in 1977. The heliosphere can be thought of as a cosmic weather front, a distinct boundary where charged particles rushing outward from the Sun and the supersonic speed meet and cooler interstellar wind blowing from supernova that exploded millions of years ago. It was once thought that the solar wind faded away gradually with distance, but Voyager 1 confirmed there was a boundary, defined by a sudden drop in the temperature and an increase in the density of the charged particles known as plasma. The second set of the measurement by Voyager 2 giving new insights into the nature of the heliosphere's limits, because on Voyager 1 a crucial instrument designed to directly measure the properties of plasma had broken in 1918. Measurements published in the five separate papers in Nature Astronomy reveal that Voyager 2 encountered a much-shaped, tinier heliosphere boundary than Voyager 1. This could be due to Voyager 1 crossing during a solar maximum activity currently at a low, or the craft itself might have coursed through on a less perpendicular trajectory than means it ended up speeding longer at the edge. The second data point also gives some insight into the shape of the heliosphere, tracing out a lineage something like a blunt bullet. It implies that the heliosphere is symmetric, and the last of the 2 points where the Voyager spacecraft crosses, said Bill Kurt, a University of Iowa research scientist and the co-author on one of these studies, that says that these 2 points on the surface are most at the same distance. Voyager 2 also gives additional clues to the stickiness of the heliosphere. the other region of the heliosphere, and the point where the solar wind flies up against the approaching wind in interstellar space, like the bow wave sent out ahead of the ship in the ocean. The data also feed into a debate about the overall shape of the heliosphere, with some models predicting out to the spherical and other more likely a wingshot, with a long tail floating out behind as the solar system moves through and the galaxy at a high speed. The shape depends in a complex way on the relative strength of the magnetic fields inside and outside of the heliosphere, and the latest measurements are suggestive of a more spherical form. They are limited to how much can be claimed from two data points. However, it's a kind of like you're looking at an elephant with a microscope. Got to say, two people go up to an elephant with a microscope, and they come up with two different measurements. You have no idea what's going on in between. From V1, the heliosphere, the sign from Voyager 2 is still being back, taking more than 16 hours to reach Earth. It's 22.4 watt/meter, has a power equivalent to a British light, which is more than a billion times dimmer by the time it reaches Earth, and is picked up by NASA's Legacy antenna, a 17-meter dish. The two Voyager probes, powered by steadily decaying plutonium, are projected to drop below critical energy levels in the mid-2020s, but they will continue on their planets long after they pose challenge. The two Voyagers will outlast Earth, said Kirk. They are on orbit around the galaxy for 5 billion years or launch, and the probability of them running into anything is almost.
They were launched in 1977. That's a long time ago. We say 41 years, but it's really two generations ago. You can think of what the technology was. Your smartphone has 200,000 times more memory than what the Voyager spacecraft has. And so it's just exciting that we've been able to get it into interstellar space.
We launched two Voyager spacecraft. They were basically the same, but they were on different paths. Voyager 2 was the one that was chosen to do the grand tour, that is to fly by Jupiter, and then Saturn, and then Uranus, and then Neptune. And then after 1989, we began what is now called the Voyager interstellar mission. We were on a path we hoped to get to reach interstellar space while we still had power on the spacecraft to transmit the data back. And that's what Voyager 1 did in 2012, and that's now what Voyager 2 is starting to do in 2018. The sun creates this huge bubble of plasma, ionized material, blows outward at 1 million miles per hour and creates a bubble. And inside the bubble, most of the material has come from our sun, and the magnetic field has come from our sun. Outside the bubble, most of the material comes from other stars that exploded 5, 10, 15 million years ago. We have an instrument which measures the wind coming from the sun, and we saw that in fact there was no longer any measurable solar wind. We had left the bubble, basically.
The team has been looking forward for this for a long time and really working hard in an engineering sense to make this day happen and to keep the spacecraft with all the instruments on so that all 5 instruments could sense the heliopause crossing and have data for that. What that means is that the Voyager 2 spacecraft is now traveling in interstellar space.
Well, this is just contributes to the number of discoveries that Voyager's been making, and this is one we'd hoped we would have the chance to do. Unfortunately, both spacecraft were still operating when they reached interstellar space. It's really quite remarkable. Voyager changed our view of the solar system, really. We saw these active volcanic activity on Io. We saw the possibility of ocean on Europa. Just time after time, we were discovering things that we had not really even imagined some years before the Voyager mission. What makes it so exciting is that not only do we confirm what we thought we knew, but even better, it tells us where we didn't know that there was something to be discovered.
The Voyagers 1 and 2 for me is amazing. It's awesome. I like so much the astronomy. When I was child, I wanted to become astronomer, but I don't like maths. In this case, it's for impossible to become the good astronomer if you don't like the maths. It's impossible. Thank you very much for watching my new video. If you want to learn English or talk with me in English, come here at the class Portuguese de Idiomas, or we can do class for on Skype anywhere in the world. Share this video with your family, friends, everyone. Thank you very much for my friends in USA, in Canada, England, in London. In London, I like so much that city. In New York City, in different countries where I speak English, Australia, New Zealand, and different places in the world. Thank you very much. And see you tomorrow with the other interesting news. Thank you very much. Bye. Good night.